today we are going to discuss one important thing, that is how the sequence detector circuit can be represented and how the design will be background process. So draw the state diagram for the sequence detector of the following sequence. So they given one sequence. So how the sequence detector will work is that some sequential input. So these input is taken from the Mealy emission output only. So when for analysis problem we will be able to get done. But here we are going to design the system. So for that we will be getting only an input sequence. So where we need to find where are the sequences detected. So two things we have to do. One is overlapping and another one is non-overlapping. So first let me do a non-overlapping sequence. For non-overlapping system I am using red color here. So the thing is that when 11011 is repeatedly identified, where the output will be 1. So here 11011 is not identified. So we have to trace from the starting bit where the 1101 is identified. So here if you see in that particular bit the 1101 is identified. Okay. So at this point the output will be 1. Okay. So at this point the output will be 1. So this is one thing. Okay. At this point output will be 1. So then again once the sequence is ended, again it need to start from second bit. So 011, so 110, here it is not here. So if you see again it will be become to the output will sequence of continuous 11011 is detected. So here this will be again the output will be 1. Okay, so this is how. So again it will start from next bit and there is no nothing. So no output will be detected here. So it will go. So only two times the output will be 1 with the help of non-overlapping detector. So this is non-overlapping. So thing is that here it is a non-overlapping. Are you guys able to understand, right? So why we are mentioning output is 1 is that at that particular time the continuous input sequence that is given here will be detected. So let us now take a blue color to find out the overlapping sequence. So same like this we will be starting from here. So from here only we will be able to get the first input, that is the sequence will be detected here. So up here only we will be able to get the sequence. So at this point the output will be 1. But here if you see, here we won't start from the next bit. So even from the subset we will be starting here. So from here itself we again start. So here we can see we have detected another one sequence. So here the output will be again equal to 1. So because this is overlapping. So here if you see, the 2 bit from the previous state of output will be taken into consideration. So lastly what we took from this input 0. But here if you see, and another one sequence is overlap 11011 and the 11 is intersection with both things. So here in the overlapping sequence this will also need to be detected. So now what will happen? It will start from again from this bit. So again it will start. So it will start from here and it will keep on searching, and here you see another one input is detected here. Okay. So even betterly what we have to do is that from here itself it will be starting from the next sequence will be started from here itself, because 110 there is 2 bit is already synchronized, right? So the best possible choose that it will pick. So from here it will choose, but there is no sequence here, only the first sequence is detected. So again the next sequence will be starting from this 11 and it will go on searching. So the sequence is not present there. So 3 times the output is present as 1 comparing to the non-overlapping. So the thing is that, so this is overlapping sequence. So now we are going to design a system that how the overlapping and non-overlapping thing will be detected in a finite state machine. So this is overlapping sequence detector. So sequence detector is one of the very important question. So last few years that is getting into more important. So let us first now discuss the non-overlapping sequence machine design. So non-overlapping sequence detector. Okay, so please try to understand carefully. So here the same analysis, present state and next state and output. Okay, so first let us consider the present state, which is equal to S0. This is initial. So initially which is in S0. So when input is equal to 0, it will go there. So when input is equal to 0, it will stay in a state 10. When input is equal to 1, it will go to next state. So this is how this is taken. So when input is equal to 0, it will go to the same state, and when input is equal to 1, it will go to next state. So thing is that here the input will be given. So input is 0 and input is 1. So input is 1 is right. So this state is considered as 1. So output will be 0, output will be 0, because when the sequence is detected then only output will be 1. So now let's take this state. So S1. So here S1 state is 1. So when input is 0 our ultimate aim is to get 1 1 0 1 1. Okay, so when input is 0, then the sequence will be broken. So already 1 is there. If 0 is common, then the sequence will be broken. So if 1 is common, then that will go to next state. So if 0 is coming, then that will be broken to first state, that is S0. If 1 is coming, then it will move to second state. So next state is 1 1. Output will be 0 in both the things. Okay, I think you guys able to get it right. So here we are getting the sequence. So when the sequence or state which is in the same track of the sequence, then it will be going to next state. When the sequence is broken, it will be again going to first state. Okay, so that is what thing. So here it is in S2. So S2 it is 1 2 2. So this is 0. So when 0 is coming, it will be moving to next state, that is S3. Output will be 0 here. When 1 is given, the sequence will be broken, so it will be again going to S2. So why this is not going to S0 is that, so here 2, so 1 is already there. If 1 is going, so this is already analyzing, so this will be going to S2. So it will be written in the same state, so that will be going to the same state. So that is why the output will be same 0. So this is this. So this is 0 and this is 1. So here the thing is S3. So S3 is in now state of 1 1 0. So when the sequence is 1, it will be going to next state. If it is 0, it will be going to initial state, because the complete sequence will be broken here, because already 0 0. If 0 is come, the sequence will be broken, so this will be going to 0 1. Okay, so this is 0, so this is 1. So 0 1. So it is in S4 now. So S4 sequence is 1 1 0 1. So 1 1 0 1. So if 0 is given, then the sequence will be broken, so it will be going to S0. If 1 is given, the sequence will be completed, then again it will go to 0 1. So it will be 0, output will be 1. Because once the sequence is detected, then it will be again go to initial state, because again it need to go to the traverse loop and it need to find the next sequence. So this is what the quite simple thing that we can do. So now let us convert this diagram into one state machine diagram. So initially the state which is S0. Okay, so when input is 0, it will return in the same state 0 and output will also 0. When input is 1, it will go to next state, that is S1. Output is 0. So input is 1. When input is 1, the output will be 0, but it will go into next state. So when the input is 0, the thing will again going back to the same thing. So input is 0 and output will be also 0. When input is 1, it will go to a next state, that is S2. So this is 1 and output will be 0. So when input is 1, then it will again reback in the same state, output will be 0. So if input is 0, it will go to the next state, that is S3. So nothing, what we are doing is that we are analyzing this purpose, we are changing this into this one. So here S3. So S3 is the when input is 0, output is 0. So here what S3 means, so S0 is nothing but 0. Sorry, S0 is 1. So S1 is nothing but 1. So S2 will be written as 1 1. So S3 which will be equal to 1 1 0. So S4 which is equal to 1 1 0 1. So S5 that we usually won't represent, so S5 we won't take. So next state will be taken as thing. So simple to take, this is 1 1. So this is sequence directed output. So S5 we won't take this one. Okay, so S4 up to S4 only will take it. So this is same thing. So when after while it is in S3, if the input is 0, then the sequence will be broken and it will be going to the same state, that is S0. So the S4 is the next state. So it will be going to S4 if the input is 1. So input is 1, output is 0. So it will go to S5 when the input is 1 and 1. So here the sequence will be completed. From S4 also it will go to S0 when sequence input is 0 and the sequence will also be broken. So this is how the state transition diagram for this one. So number of states n is equal to 5. So number of flip flops required is equal to 3. Okay, so now what you can do, now you can write a table like present state, next state, input, output, any kind of flip flop you can use, and you can even draw the circuit. So that is not needed. So thus they ask us to draw the finite state machine diagram only. So that we have done. So this is for non-overlapping. So now we have to discuss about overlapping sequence. So overlapping sequence also very similar, but there is a quite logic we have to take into observation. Please carefully listen this one. So overlapping sequence detector. Okay, so similarly like how we previously started, the same thing. So present state, PS, input, next state and output. Okay, so the initially present state that will be S0. Okay, so when the input is 0, that will be going to S0, same S0. When input is 1, it will be going to next state. So that is 1. Output will be 0 0 in both the cases. So here it is 0, here it is 1. So S1, the sequence is 1. So when it is 0, it will be broken to S0 and output will be 0. When the input is 1, it will be going to next state, that is S2, and output will be 0. So here it is S2. So S2, which is nothing but 1 1. So it is 1 1. So here if it is 0, it will be going to next state, that output will be 0. If it is 1, then it will be again going to S2 state and output will be 0. So thing is that this is 1 1. So here it is 1 1 0. So here S3 is nothing but 1 1 0. So when input is 0, the sequence will be broken. So this will be going to S0 and output will be 0. When input is 1, it will be going to next state, that is S4, and output will be 0. So S4 state, so where it is 1 1 0 1. So simple thing that it will be going to 0 if it is input is 0. So it will going to S2 S2. So here in previously what we see is that it will be going to S0 because the sequence will be completed. But here if you see there is some overlapping. So once this is done, it will not go to S2. It won't start from here. It will start from here. So this will be after 1 1. It will be in S2. So this is 1 1. So this is the only one difference that we'll be having here. Okay. So rest all things is same. So only thing in the sequence detector for this input, this is if the input is different, then the sequence will be changed. So let us now draw the sequence state diagram for this one. So it is initially in S0. So it will be in the same state if the input is 0 and output will also be 0. It will go to S1. Let me draw all the state. So it will go to S1 if input is 1 and output will be 0. It will go back to 0 if input is 0, output will be 0. It will go back to next state when input is 1, output will be 0. So it will stay in the same state if input is 1 and output is 0. So it will go to next state if input will be 0, output will be 0. So it will go to next state if input is 1 and the corresponding output will be 0. And the sequence will be going to 0 broken state here. So it will be going to previously from S4 it will go into S0, but here if you see it will be going to here. So when 1 and output will be 1. So from S3 also it will again go to S0. So when that is only possible with input is equal to 0 and output will be 0. So this is what the finite state machine for the overlapping sequence. So I hope you guys able to get a good understanding of the thing that how we can do the sequence detector, that is overlapping or non-overlapping anything. So I'm leaving here. So please try to do this. So here we can. This is not ended here. So I have just drawn the FSM. So finite state machine diagram only. State machines only we have done. So here you can analyze present state, next state, the input and output. So those things you can analyze both Mealy and more you can try, but here we have used Mealy system only. So more system also you guys can try and do it, but mostly sequence counter we can use Mealy system only because that will be quite easier for us to analyze. So if more system is come, then what we'll do, this output will be presented inside. So this output, the bar after the input bar output there is that. So this will be changed. So this will be going to inside. So that will be the only one change. So okay, so next class we'll be solving some gate previous year question. So stay tuned guys. So please revise all the concepts and come to next class. So there we will be solving some good problems. So thank you guys. Stay tuned, like, share and subscribe the channel.